Hello everyone, welcome to the channel uLearn Education Online. In the previous video, we have seen how to generate the PPM signal, and also we have seen what is the circuit that is used in order to generate the PPM signal and also the corresponding waveforms. In brief, we can say that here the PPM signal is not directly generated from the message signal and the carrier signal. Here it will generate from the generation of a PWM signal. That is, first we have to generate the PWM signal from the given message signal and the carrier signal. Thereafter, by using a monostable circuit, this PWM signal is converted to the PPM signal. Whereas in demodulation process, we go in the reverse method. That is, first we have to generate the PWM signal from the PPM signal. Thereafter, the generated PWM signal is passed through the PWM demodulator circuit in order to retrieve our message signal that is transmitted during the transmission. So it is the reverse process we are using. And now let us see what are the blocks that are involved in order to generate the message signal from the received PPM signal. If you observe this, the PPM signal mainly consists, the demodulation of PPM signal mainly consists of 4 blocks. One is the pulse generator, second one is the reference pulse generator, third one is the SR flip-flop, and fourth one is the PWM demodulator. As we know that here the PPM signal that is transmitted from the modulation circuit will get distorted because of the noise present in the environment during the transmission. So at the end of a demodulator circuit, that is the input of a demodulator circuit received is a PPM distorted signal. In order to obtain the distortionless message signal, here the distorted PPM signal once passed through the pulse generator and thereafter given to the flip-flop. Here the pulse generator used in this circuit will produce a pulse waveform with a fixed duration, and then it is applied to one input of a reset flip-flop, that is R pin of a flip-flop circuit. Whereas this reference pulse generator will produce a reference pulse with a fixed period once a PPM signal is applied to it, and thereafter the output of a reference with fixed period pulse is given to the set pin of SR flip-flop. Okay, so here from the pulse generator we are obtaining a pulsed signal with a fixed duration, whereas from the reference pulse generator we are obtaining a pulse signal with a fixed period. Because of the pulses that are applied at the two inputs of SRR of the flip-flop, it will generate a PWM signal. Okay, further this PWM signal is passed through the PWM demodulator circuit in order to retrieve the message signal from the incoming signal. In this way, we are going to retrieve the message signal from the received PPM signal. So this is the block diagram that is used in order to retrieve the message signal from the original PPM signal. Now let us see how the PPM signal is converted to PWM signal. So here these are the pulses that are present from the reference or that are generated from the reference pulse generator circuit and is given as input to the SR flip-flop of S pin, whereas these triggering pulses or the pulse generated pulses that are given as input to the reset pin of an SR flip-flop. Due to this, S and R signals applied to the SR flip-flop will generate a PWM signal. Okay, so thereafter this PWM signal is applied to the PWM demodulator circuit in order to retrieve the original message signal.